Hello everyone, welcome to Chip Confusions. Today we shall see how to write a constraint to generate powers of any given number. In the previous video we saw how to generate powers of 2 in multiple ways. In this video we are going to see writing a constraint to generate power of any given number. For that, first we have to write a class. Name of the class, semicolon, and then ending with end class. Now we have to declare the class variable. We have to declare it with rand keyword so that the randomization will work on this variable, and let us take it as int. Till now we were working on bit type. Let us take int now and try. Let the name of the variable be a. Now we have to take another variable and we have to randomize it also. Let it be bit 4 down to 0 and power. So we have declared two variables. One is of int type and the name of the variable is a. Another is bit type with 5-digit vector, that is power. Now we have to write the constraint. Let the name of the constraint be C1 enclosed within two flower brackets. Now we have to write the condition. Any given number, let us say the given number is 3. So now we have to generate powers of 3. So it is the same way as we did in the previous video, that is the variable a must be equal to 3 and the exponential operator, and then we have to write power variable here. So whenever this power variable is randomized, whatever it is, the value it is getting, that value will be assigned here, and that value for that power a will get the randomized result. Now for randomization we have to write a module. Let the name of the module be tb and then end module. Now we have to declare object of class type, that is my class. Let the name of the object be MC, and here only we are writing the constructor. We can write inside the initial block also, otherwise we can declare it like this. Now we have to take initial block begin and end. Yes. Now we have to randomize, and before randomizing we have to repeat it, say for about about 5 times. In between begin and end, inside that we are randomizing the object, mc dot randomize, and then we have to display the randomized result. Variable is a is equal to %d comma mc dot a. Whenever we are using a class variable outside the class, we have to access it through the object of the same class. Now our code is done. We have to see the result now. We have to select the simulator here, then we shall run. Yes, so we are able to see the power generated in terms of powers of 3. We can minimize it by minimizing this power variable value, that is the size of the power. We can see the result now. Yes, we are able to see the result. It is getting repeated, so we can use randc so that the value will not get repeated. Yes, we are able to see the output now. Now we did for 3. Same thing we can do for any other number. We can do for even 10 also. Yes, we are able to see the numbers generated in terms of powers of 10. Like that, for any given number, we can generate the power of that number by writing this constraint. Let us see for 4 now. So, to generate power of number 4, we can write this way. This is one of the straightforward ways to generate the powers of 4. We will run the code and see now. Yes, we are able to see the powers of 4 are getting generated. Now there is another way to generate the power of number 4. That is, what we have to do is, we had seen in generation of power of 2, like we were taking 1 and we were left shifting it to power times. This we were doing for generating powers of 2. What we have to do now, and we know how it works also, and if you have not checked this video, please check SV constraint 6, where I have completely explained about how we are going to generate the powers of 2 in multiple ways. In that, this is one of the ways. Now concentrating back on this, this is for generation of power of 2. How we can modify this so that it will be able to generate powers of 4, that we will see this side. Please concentrate on the design side. What we have now is 1 left shifted by power times. This is the condition we have, and let's say power is 1. So if 1 is shifted left by one number of times, means this will be 1 0. This is nothing but 2. This is 2 power 1. Same thing if we modify so that it will be able to generate power of 4, means what we can do is 1 shifted by 2 times, which will be equivalent to 100, which is equal to 4, which is nothing but 4 to the power of 1. Next, if the value of power is 2, then if 1 is left shifted by 2 times, means this will be 100, which is equivalent to 4, which is equivalent to 2 power 2. Same thing, if 1 is left shifted by 4 times, this will be equivalent to 1 followed by 4 zeros, which is equal to 16, which is nothing but 4 power 2. In this pattern, if we see, if 1 is shifted by 2 times the power variable, we can get the values in terms of powers of 4. Let us check here whether it is generating or not. Let us enclose this with normal brackets. Now we shall see whether this condition is working or not. I am commenting this out so that in future we can refer. Okay, let us run the code now and see what result it is generating. Yes, so we are able to see this is generating in terms of powers of 4. We can limit it to 2 so that we can know the numbers, means it will generate the smaller numbers. Yes, we are able to see 256, 64, 1, 16,384, 4096. Okay, these are all in terms of powers of 4. So we got to know what is the general way to generate powers of any given number, and particularly for 4 we got to know the two ways by which we can generate powers of 4. This is all for this video. Thank you so much for watching this video. In our next video we are going to see some other constraints. Keep coding along. Thank you so much. Please like, share this video and subscribe to my channel for such more videos. Thank you. Have a great day.